Hey gang, this is just a quick walkthrough of part A of the new Trigonometric Identities and Formulas classwork, chapter 11. You don't have to watch this. I'm not really going to do anything that's new, but if you've been going through part A and there's anything that you're kind of hung up on, I'd fast forward through this video to that part and see what I have to say about it. Might help, might not, I don't know. And I'd also check the answer key too. So this is definitely, again, not required viewing for anybody. So the section starts out with this picture. Trig is a song. Cosine G, tan G. It doesn't really make much sense. Or it doesn't seem like it does. What we're trying to do is to introduce the idea that you can rewrite expressions that have trig functions in them by doing substitutions. Various combinations or forms of trig expressions can be rewritten in lots of different ways that are equivalent. And so that's what this is getting at. So the example shown here, we have number one here, cosine G times tan G. So this is weird expression that we're starting with. Now, you might remember from something that the tangent of an angle is actually equivalent to the fraction, the sine of that angle divided by the cosine of that angle. And if you think about it, when you go back to the unit circle, we said that the tangent was y over x, and the cosine of an angle is the x coordinate. And this is, again, thinking about a unit circle and the position of points on that circle as you go around. The x coordinate of a point is the cosine, and the y coordinate of a point is the sine of the function. So we also said that the y over x, or the slope of a ray on the unit circle, is equal to the tangent of the angle. Well, if that's true, that the tangent of an angle is equal to y over x, then if x is cosine and y is sine, it should be true that the tangent of an angle is equal to the sine of the angle divided by the cosine of the angle. So that means that over here, we started with tangent of g. We can rewrite that as the sine of g divided by the cosine of g. Now, with this expression, we've got some simplification we can do, because we have cosine of g times sine of g over cosine of g. This is really cosine of g over 1. And if we multiply it together, we're multiplying across. We're going to get an expression that's a fraction with cosine of g in the numerator and cosine of g in the denominator. So we can cancel out cosines of g. Now, it's important to realize when you're doing this sort of thing that if you look at this fraction here, you can't cancel the g's. Sine of g and cosine of g, each of those things is an entity that's sort of self-contained. You can't cancel things from within that. So sine of g represents a number and cosine of g represents a number. You can cancel things that are the same, but you can't cancel out the argument to sine and the argument to cosine. But cosine of g and cosine of g, those two are identical. We can cancel them. So once we've canceled those two cosines, we're going to end up with just sine of g. You know, sine g, S-I-N-G, sing, get it? Get it? Sure, I get it. And trig is a song. Sing it. Okay, it's not very funny.